Hello, good morning everyone. So let us talk about a chapter known as circular motion today. So I am Dr. Ratankar and I teach physics for an international school in Bangalore. And this course details about circular motion and it is suitable for those who are studying on IBDP, IGCSE, CPSC, JEE and other competitive examinations. And this is my website for those who are interested. It is known as k12physics.com. For those who are interested in solving or understanding physics using numerical examples, you can go through it. Okay, so let us move on directly to the topic. So uniform circular motion. So what is uniform circular motion? It can be described as the motion of a particle in a circle, but with a constant speed. So as you see, when a particle is moving in a circle, it can now move with a constant speed. As you see, this vector v, the velocity vector, is seen to be a constant over here, but maybe the direction of v is changing everywhere. See, here it is towards north, here it is towards east, and now it is downwards, and here it is towards west, and so on. Okay, so it is changing its direction. At all instances, the object is moving tangential to the circle. So at every position you see, it is moving tangential to the circle. And as an object moves in a circle, it is constantly changing its direction. So it's constantly changing its direction. Now, some of the examples are being given over here. As you see, it's nothing but a rotation of a cycle wheel. Now, as it starts rotating over here, so how does it changes? And then we also seen about the rotation of a disc, okay, which is the rotational axis. And then you can also see a person which is being revolving or rotating around in a vertical circle, right? And in each and every case, it is moving in a circle. And shown here is nothing but an example of a car which is moving in a vertical cylinder. And the last example shown over here is nothing but a charged particle in a magnetic field. Students who have already studied magnetism or electromagnetism in detail, they will get to know, okay, so why the particle is moving in a circular field, in a magnetic field, in a circular motion. Okay. Now, what is the difference between uniform circular motion and uniform linear motion? So this is something which we need to address, right? So the reason is because, so we already studied about uniform linear motion, which is a one-dimensional motion. What do we mean by one dimension? Which means you just require only one dimension, that is either X or Y, to understand what is the displacement of the particle or whatever you need to understand about a particle, right? So this was one dimension. But if I am talking about a uniform circular motion, you see, as the particle moves, you have to specify the X and Y coordinates everywhere over here, right? You need to specify it. Thus, it is a two-dimensional motion. Next, coming back to the displacement. Displacement of a particle in a uniform circular motion can be zero, which means, let us say it starts from here, and if it completes one full circle, it becomes zero, right? The displacement is zero. But in case of a uniform linear motion, a particle starts from here and keeps on moving in a straight line. Then in that case, the particle's displacement never becomes zero. Then the speed or acceleration, if you look at, the speed remains a constant in case of a circular motion, while the direction of speed changes continuously. So this is what we have observed so far. But in case of a linear motion, the speed remains a constant with this direction, and hence the acceleration is zero, right? That's where this uniform comes in. Okay, so therefore, in fact, strictly speaking, when we talk about uniform here, we should only say that uniform here refers to the speed being constant, and uniform here refers to the speed and the velocity being constant, right? So non-uniform circular motion is a motion denoting a change in the speed of a particle moving along a circular path. When the particle is moving along a circular path, the speed of this particle keeps on changing, which means what? Here, let us say it is going slower, right? Here it is going slower. Now, as it keeps on going upwards, the speed keeps on changing, right? As you see, the green color, the vector which is shown over here is increasing constantly, right? So this, see, here it is much smaller. Now, as it keeps on going down, okay, so it keeps on increasing, which means the speed is now increasing, right? So this is nothing but your non-uniform circular motion. So how do you differentiate between uniform and non-uniform circular motion? In uniform circular motion, speed is constant. In non-uniform circular motion, speed is also not constant, right? So therefore, you can expect that there will be an acceleration due to a tangential velocity and also an acceleration to the change in the direction. Anyway, we'll come back this in detail when we talk about the non-uniform circular motion. Right. Now let us understand about axial and linear vectors. It is something which is very important to understand at this point of view, because we have to measure something, and when we are measuring, you will always ask the question whether it is a vector quantity or a linear quantity. It's a scalar quantity. So an axial vector is also called as a pseudo vector. A pseudo means what? Which is not existing, right? Which is not existing or which exists only under certain conditions. So it's a quantity that transforms like a vector under a proper rotation. So therefore, now let us say, for example, a particle is at rest here. It doesn't have any axial vector. And the particle is rotating, then only you can have an axial vector. The axial vector here is directed upwards. As you see in the diagram here, so you have a particle which is being moving in a curve in a different plane. This is one vector, the brown color vector, and the green color vector, two different vectors, which are often changing its directions. But the blue color vector is always pointing upwards, right? If it was a horizontal plane, definitely it have been moving, it have been pointing upwards in the same direction forever, right? So therefore, this is an axial vector. Then, how do you know what is the direction of the axial vector? The direction of the axial vector is obtained using your right hand grip rule, which means that if I hold my right hand like this and the fingers are curling inwards like this, it's curling inwards. Okay, you see the direction of the fingers is like this, it's curling inwards like this, which tells you the direction of the particle. Then the axial vector is nothing but directed upwards, which is indicated by the direction of the thumb. Now, if suppose the fingers are downwards like this, say for example, the finger is going like this over here, tip of the fingers are shown like this over here, then the axial vector is pointing downwards, which means, okay, the axial vector is pointing downwards. Now, let us take up one more case. Let us say, for example, it is like this, it is towards you now. Now, how is the axial vector directed? The direction of the thumb, which is directed towards you. Now, you see, this is now moving in this direction, the particle is moving in this direction, which is indicated by the fingers, and thus the axial vector is directed towards you. Now, if I flip my hand like this, now what happens is the particle is moving in the anti-clockwise direction. Then the axial vector is directed towards me or away from me. Thus, if you consider that this direction is positive, that is towards you is positive, then away from you is negative, right? It depends only on which direction is positive, and thus you can have only positive or a negative vector based on the directions. You don't have it like X and Y, but sometimes this axial vector is directed along the Z axis. Now here you see this is directed along the x-axis, this is along z-axis, and this will be along the y-axis. Okay, let us move on about the parameters of a uniform circular motion. Like for example, when if I ask you about what are the parameters of a linear motion, then you will always say distance is one of the parameter. How do you measure a linear motion? The particle is moving in a straight line. Distance could be one of them. Displacement could be the other one. You can always say speed is the other one, right? These are some of the parameters. In a similar way here also, the particle is moving in a circle. As the particle is moving in a circle, it will describe a small angle here, right? It's describing a small angle, theta over here. So theta could be one of the parameters. Thus, here instead of talking about displacement, you can now talk about an angular displacement. The angular displacement is nothing but the angle described by the particle in a circular motion, okay, in a given time t. So therefore, this is the angle described. You can say the theta is equal to 10 degree, 15 degree, 30 degree, 45 degree, whatever it is. Okay, the 360 degrees. You can mention whatever it is. Then you can also see that angular speed, like similar to that of your linear speed, you also have an angular speed, which tells us the total distance divided by total time taken. So in which case, in linear speed, you can define it as total distance by total time taken. In angular speed, you can refer to as total angular displacement by total time taken. Okay, so that's what you can say. An angular speed is a magnitude only. It means it's only a scalar. It is not a vector. When I am talking about an angular velocity, which we had seen previously, angular velocity vector is nothing but calculation of the angular speed with the direction of the vector clearly specified. Okay, now we have seen what is angular speed and angular velocity. Then what is period? Period is nothing but the time taken by the particle to complete one full revolution, right? So, and it takes a time of 2 pi radians to complete, it takes a time t to complete one full revolution, which is 2 pi radians. What is 2 pi radians? Which is 360 degrees, right? Particle starts from here, goes around the circle and comes back to the same position. It covers around 360 degrees. The time taken to cover 360 degrees is nothing but the time period. Frequency, it is defined as the rate of rotation or the number of rotations in some unit of time, right? How many rotations does it perform in 1 unit of time? Let us say in 1 time period, okay? So 3 rotations are possible, right? So then you can say that a frequency is nothing but 3 times per second. So in 1 second, okay? So what is the number of rotations which are possible? So usually the frequencies unit is said to be hertz. These 3 quantities are related by the equation F equal to 1 by T. What is 1 by T? 1 by T is nothing but T is the time period So reciprocal of frequency, time period is a human frequency, which can also be written as omega divided by 2 pi. Okay, so time period can be written like this. In other words, if I want to find the linear speed of the particle undergoing a circular motion, I can write linear speed. What is linear speed? The speed of the particle in the tangential direction, in this direction. Okay, so which is equal to r into omega, which should be r into whatever is the value of omega. Plug in the value of omega. Omega is nothing but 2 pi by t. So substitute that value and you get this expression over here. Okay, so let us move on to the next part. Right, non-uniform circular motion, we'll discuss it at a later stage. So with this, we come to an end for the chapter. Okay, so next class, we'll look into more about non-uniform circular motion. Thank you.